theorem of parallel axis. Theorem of parallel axis. Okay. It states that it states that the moment of inertia of body, the moment of inertia, the moment of inertia of a body about any axis, about any axis is equal to the sum of is equal to the sum of its moment of inertia about a parallel axis through its center of gravity through its center of gravity and the product of its mass and the square of the distance between the two axes. Okay. It states that the moment of inertia of a body about any axis is equal to the sum of its moment of inertia about a parallel axis through its center of gravity and the product of its mass and equal of the distance between the two axes. Okay. Theorem of parallel axis. It states that the moment of inertia of a body about any axis, the moment of inertia of body about any axis is equal to the sum of its moment of inertia about a parallel axis through its center of gravity and the product of its mass and the square of the distance between the two axes. Okay. Let CD be an axis. Let CD be an axis in the plane of the paper, and AB is the parallel axis. AB is the parallel axis through G, the center of mass of the body. Through G, the center of the mass of the body. G is the center of the mass of the body. The perpendicular distance between the axes is h. The perpendicular distance between the axes is h. Let m be the mass of the body. Let m be the mass of the body and m1 the mass of the element at distance x1 at p distance x1 from AB, distance x1 from AB, okay? Distance x1 from AB, moment of inertia of m1, so moment of inertia of m1 about CD equal to m1 x1 plus h whole square. Moment of inertia of m1 about CD equal to mass m1 multiply distance x1 plus h whole square, okay, equal to m1 x1 square plus h square plus 2 x1 h. Okay? And that is m1 x1 square plus m1 h square plus 2 m1 x1 h. Okay? Moment of inertia of the body about CD. Moment of inertia of the body about CD, about CD. I equal to sigma m1 x1 square plus sigma m1 h square plus 2 sigma m1 x1 h for full body. If Ig is the moment of inertia of the body, if Ig is the moment of inertia of the body about AB and axis through capital G, then sigma m1 x1 square equal to Ig. Sigma m1 x1 equal to Ig. So I equal to Ig plus mh square. Ig plus mh square plus 2h sigma m1 x1. Okay? Now sigma m1 x1 is the sum of the moment of the particles about AB passing through G, the center of gravity, since the body is balanced about the center of mass capital G. Therefore, the algebraic sum of all the moment about G is 0. So sigma m1 x1 equal to 0. Hence I equal to Ig plus mh square. Okay? Theorem of parallel axis. It states that the moment of inertia of a body about any axis is equal to the sum of its moment of inertia about a parallel axis through its center of gravity and the product of its mass and the square of the distance between two axes. Okay? Let CD be an axis in the plane of the paper. Let CD be an axis in its plane of the paper and AB a parallel axis through G, the center of the mass of the body. The perpendicular distance between the two axes is h. The perpendicular distance between two axes is h. Let capital M be the mass of the body and m1 the mass of the element at p distance x1 from AB. P distance x1 from AB. Moment of inertia of m1 about CD. Moment of inertia of m1 about CD equal to m1 x1 plus h square. m1 x1 plus h whole square. Solve m1 x1 square plus m1 h square plus 2 m1 x1 h. Moment of inertia of the body about CD. Moment of inertia of the body about CD. Moment of inertia of the body about CD. I equal to m1 sigma m1 x1 square plus sigma m1 h square plus 2 sigma m1 x1 h. Okay? If Ig is the moment of inertia of the body about AB, Ig is the moment of inertia of a body about AB and axis through capital G, then m1 x1 square equal to Ig. m1 x1 square equal to Ig. m1 x1 square equal to Ig. Okay? Ig. So I equal to Ig plus m1 h square plus 2h sigma m1 x1. Okay, but sigma m1 x1 equal to 0 because now sigma m1 x1 is the sum of the moment of all the particles about any passing through the center of gravity. Since the body is balanced about the center of mass capital G, therefore the algebraic sum of all the moment about G is 0. So sigma m1 x1 equal to 0 and psi equal to Ig plus mh square. Okay, note. And next heading, moment of inertia of a circular disc about an axis through its center perpendicular to its plane. Okay, next. Thank you.